So I've had the Raspberry Pi 5 and the AI Hat for a few weeks now, and I've been doing some experiments with it outside in my enclosure. I've been trying to determine how long it will last off of battery power alone, and from my experiments it seems to be achieving 8 hours of operation just fine, with my batteries giving about 41 watt-hours of usable capacity. As I've mentioned before, unfortunately the UPS doesn't have any way of measuring power consumption, and I really want to know what this number is, so I have a USB-C inline power meter to measure the power usage. To my surprise, when running my object detection model at 30 frames a second, it only used just over 5 watts of power, rarely ever peaking above 6. This is a lot less than some numbers I've seen online, but is actually in line with my experience with my real-world experiments. If I were to drop that down to 5 frames a second, which is what I was doing with the outdoor experiments, you can see it drops right back down to under 4 watts, about 3.8, 3.9 watts on average. And with a usable capacity of about 41 watt-hours, the 4 watts of power consumption explains the battery life I was seeing in my real-world experiments. For reference, when the Raspberry Pi 5 and AI Hat are idling, they consume about 3 watts of power, so while running at 5 frames a second, the Halo accelerator is only using about 1 watt. Now of course, when I've got this set up outside, it's connected to a 30 watt solar panel as well, and with that the system is easily able to last the whole day with the battery still charged. Now back to the UPS I'm using. I mentioned in a previous video that I was really struggling to find a suitable power supply for my system, and I settled on this UPS as it was the best that I could find, and though it didn't fulfill all my requirements, at the start I was pretty happy with it. After playing with it for a while though, it does have some weird quirks that make it kind of unusable for the application. The main issue is that for some reason, when the Raspberry Pi shuts down, the UPS detects this and shuts down the power supply to the Raspberry Pi as well. I think this is an efficiency thing, so it's trying to conserve battery power by shutting off the buck boost converter, but what it means for me is that I'm unable to use the real-time clock's auto reboot for the Raspberry Pi 5 to reboot the Raspberry Pi after a set period of time, because there's no power connected. Other than that, there's also no way to reboot the Raspberry Pi once the battery voltage has reached a reasonable level like I was doing in my old system. What these two things together mean is that the Raspberry Pi will only reboot once shut down once the UPS has received an external power supply, aka the solar panel starts producing power. What this means for my system is, once the Raspberry Pi has shut down for the day, it will not reboot until the next day when the sun comes up and powers the solar panel, which means if it's an overcast day, even if the batteries are fully charged, the Raspberry Pi will not start up. So while the UPS has been okay for now while testing everything else out, I am seriously now considering finally just biting the bullet and designing my own power supply that has everything that I want in it. That includes maximum power point tracking for the solar panel, an onboard microcontroller to monitor the state of the battery and reboot the Raspberry Pi when I want to, onboard communication with a LoRa module, a small OLED screen to display status, and some other basic features as well that will allow me to create the perfect remote self-contained edge compute system. I've received plenty of messages as well from people trying to create their own system like I've done here, and they're also having problems with the power supply system. So if you're interested in having a battery powered supply like I've described, let me know, and let me know what features you'd like to see. I might end up turning this into a product. In any case, remember to follow to stay tuned for more.